What I'll now show you how to do is cable PD readings. So what you'll need is a HFCT. This is a HFCT, a high frequency current transformer. It's magnetic. You can zip tie it there if you need for permanent installs. And this is the cable that you need. So what we do is we plug this one into here. When we plug this in, it'll change from TEV to cable PD, as you can see there. And then what we'll do is we'll plug the other end of that into here. So now PD information or PD signals are coming from the inside of this high frequency current transformer. What we can do then is we go cable PD and we look at the different measurement modes. So first of all, we've got the very simple one, which is measure, which tells us our picocoulomb level, pulses, severity, and it will show us what sort of PD levels have been picked up over time. I've just turned on my PD source here, and I'm going to put this around my PD source, which will pick up some signal for me. So that's how that screen works. Next screen is your phase plot one. This is the one we use most of the time, and this is the one where we can see our phase plot coming through. So I need to change my phasing down to my phase lock down to something that's a bit more closer to my source here, which my source is running at 49.73 odd hertz. Yeah, you can see there that everything's staying still for me on the screen. So it's around about that. You can see your phase plot, your picocoulomb level, your pulse per cycle count. If we go to settings, again, you can listen to ultrasonics with your headphones if they were plugged in. You can also listen to cable PD. So if you click cable PD, put your headphones in, you'll hear the sound that's coming in through this high frequency current transformer. Some people find that useful, some people don't, but it's possible. Again, you can mute your headphones or you can turn the volume up and down on your headphones. That's how that works. Next one is your filtering. So your filtering is very important with the HFCTs. Default mode is there is no filter. So all the information that's coming through here is not filtered at all. What you see is what you get. It's capturing everything that it can. What we do is if we go to the filters and we change it to a 500 kilohertz high pass filter, it'll let everything through above 500 kilohertz. Click the X button, refresh this, and we can still see a lot of PD coming through here from our test source, and that's because there must be a big component above 500 kilohertz. If I then change my filtering to 1.8 megahertz, hit the X, again, we can still see the PD coming through, but generally it drops in amplitude. May not always. So if I just change them, we've got 1133, go to that one. This goes to 1793, and then no filter, 1665. This is an artificial source, so it's just the way that source is behaving. Generally, when you're detecting real cable PD out in the real world, the number will drop down each time and the phase plot will clean up and you'll get less and less noise. Again, we have the option to hook onto our photo mode, e-field mode, wireless phase reference or manual to get our nice phase lock that we want to have for our readings. So if I click on the settings button again, it gives me this option here to choose a different HFCT. So I've got RFCT, HFCT 50, HFCT 100, which is the bigger one. And then you've got that custom HFCT. That's where you can set a custom, you can plug into other manufacturers' HFCTs basically and calibrate your instrument to that. I'll show you how to do that in a sec, but we would set it here to HFCT 50. That's how that works. And then the other, you've also got persistence mode. So if I go to persistence mode, turn it back from infinity. Okay, so in persistence mode, it will refresh your phase plot for you without you pressing the pause refresh button. All right, the next thing is the histogram. Again, that will just tell you where the pulses are occurring relative to a decibel level and the waveforms. So this is where you can see the PD pulse coming through. You'll see how that's a nice, clean, tight PD pulse. If I turn my instrument off, my test source off, that will completely change. And you can see there that there's absolutely no pulse coming through as well. And turn the pulse back on and it gives me this. Now in real life, if you were doing some cable PD readings, you'd be able to have a look at this trace here and you'd be able to figure out where your pulses are along your cable and you can figure out the distance to PD along the cable. Okay, and that is how you take HFCT readings. The way that you change that custom HFCT that I showed you before is if you go to settings, measurement settings again, and then this custom one here, custom HFCT. So you can change that number to whatever you want to tune another manufacturer's HFCT to this instrument, and you do that on your own. In a test lab, we can't tell you exactly what those numbers will be, and that's HFCT reading.